This is problem 1 on practice exam 2 of chapter 2 in the book Problem Solving with Differential and Integral Calculus. The flow rate of a fire hose is about 1.5 gallons per second. And we're going to assume it's continuous, so it's not like water molecules coming out. It's continuous. What is the time needed for a cubic centimeter of water to exit the hose? Note that there are about 3785 cubic centimeters in a gallon. In part B, as for the infinitesimal volume dV that comes out of the hose in dt. It is this part that we have to assume that water is continuous and not composed of H2O molecules. So let's tackle part A. It's a simple rate equation. V is 1.5 gallons per second T. So in 2 seconds, 3 gallons come out. Simple. We're given the volume. We're given V. 1/3785 of a gallon, 1 cubic centimeter. So we substitute this in for the volume, and we want to solve for T, so we divide both sides by 1.5 gallons per second. The gallons cancel. We have a 1 over T, 1 over seconds in the denominator, which makes it seconds, and we get 0.00018 seconds, which is less than 1/5000th of a second to get a cc out of a fire hose. Part B, what's the infinitesimal volume dV that comes out? Now, if you're not familiar with infinitesimals, you're not comfortable with them, you might have trouble with this one, but after a while, you're just going to write it down because it's obvious to you. So we have this normal equation, and we want to know how much comes out in dt, some infinitesimal time. And if you plug in dt to this equation, you're going to get dv. So you just plug it in, and that's what you get. And that's the answer. dv is 1.5 gallons per second. dt, the flow rate, dv dt, is 1.5 gallons per second. So dv is 1.5 gallons per second dt. That's problem 1. Straightforward. You understand infinitesimals. It's not magic.